Welcome. Glad you're all here. Excited to get to talk to everyone today. So yes, for anyone who doesn't know who I am, I have been at Sauce Labs for 3.5 years now. Before I joined Sauce, I worked as an SDET at several different companies, writing frameworks and various other implementations of different contexts of testing requirements. While I was doing that, I got involved in the open source community. It's one of those find a problem, try and fix it, realize that it's not your code, it's their code. And so you go and fix their code. And I did that with Water, which is a test library based on Selenium. And so I did that enough that they let me be the project lead. And then I did that for Selenium enough that they had me become a core contributor. And now I am on the technical leadership committee for Selenium. And I'm also a part of the World Wide Web Consortium browser tools working group for WebDriver specification. And I can answer questions about that if anyone has. I'll talk about that a little bit in this as well. So I've done a lot with code. I've done a lot with Selenium. I've done a lot with implementations on top of Selenium. And so we're going to try and keep this Selenium 101 relatively basic. There should be some stuff that more advanced users will get things out of, and then we can have conversations about diving deeper into some of the topics. So just overview, what all is Selenium? Essentially, we've got a monorepo, which is all of the code for Selenium is stored in one repository on GitHub, including some of our built binaries, which is not usual for GitHub, but that's the way that Selenium wants to do it. We want to make all of the resources that you need to build it should be available to you in the project itself, is the philosophy that we go with. So in the Selenium repo, you have the Selenium server, and you have different modes that it can act in. So this is, you can have a standalone, you can have it act as a hub or a node for a grid. Then you have the Selenium client libraries, or the language bindings as we refer to them. This is what most people think of when we talk about Selenium. And I'll go through what those are doing here in a second. Selenium IDE, I am not going to spend a lot of time talking about Selenium IDE. It is a record and playback tool. It was initially a Firefox extension, and then Firefox at a certain point discontinued its usage for security reasons. And then we have a new revitalized next generation Selenium IDE, which was not quite fully functional relative to what we had before. And in general, I'm not a huge record and playback advocate anyway. So there's something out there. It can be used in general. If you're going to use it, do so sparingly and don't base your entire test suite on it. And then the last thing that is a part of Selenium, a repo, is the drivers. We, on the Selenium project, used to have all of the browser drivers as part of the project. And as we developed and became more mature, as we moved into the W3C process for standardizing the WebDriver protocol, the browser vendors themselves came on board and took over responsibilities for creating their own drivers. And so the only driver that is still left in the repo at this point is the Internet Explorer driver. Essentially, Microsoft looked at it and said, hey, Jim Evans, you did a really great job doing this. We're going to focus our time and energy on Edge, and we don't need to do our own Internet Explorer one because what you've got is so good. So Selenium, and this is mostly the bindings. Like I said, this is what most people think of when they think of Selenium. Is it a testing tool? I see when I ask this question live, I see way too many hands get raised when I ask if this is the case. What does it do well? So Selenium is not itself a testing tool. It does a great job of being the robot. You tell Selenium to do something specific and it will go to the browser and do that thing. It will either take an action or get information. And that's pretty much all it's doing. It's a low-level toolkit. What it doesn't do as well is it doesn't account for test logic. It doesn't do things that actively interact with the operating system itself. It won't parse HTTP responses, and it's not the best way to evaluate the overall performance of your site. So there's a lot of things that Selenium people use it for that it's not really designed for or it can't do. And I think this is one of the primary frustrations I have as a Selenium developer. I'll tell people that I'm a core contributor to the Selenium project, and then I'll get developers say, oh yeah, I used Selenium once, it was really frustrating, I hated it, and I stopped using it. And it's like, well, I understand the logic behind that. At the same time, a lot of people are blaming the tool for things it wasn't designed to do. And we can get into a longer discussion about what it should and shouldn't be designed to do, but most of the problems with Selenium come in how it is implemented. And so most of my energy for the last 5 years has been, how do I help people better implement their Selenium usage so that they're getting the actual value that Selenium is making available. There are alternatives to Selenium out there. Very few of them have the underpinnings that are as robust and as effective at emulating what users do as Selenium. Some of them add the extra stuff on top. Anyway, we'll move on to more Selenium, and then my just generic Selenium is a project that includes libraries in multiple languages, where each library provides a language-specific interface to implement the WebDriver protocol, which enables you to programmatically interact with a browser to simulate user interaction. All right, so some quick history on Selenium since we're doing a 101. Selenium started at ThoughtWorks in 2004 with Jason Huggins, who was tasked with writing some kind of accounting software, and he wanted to test it. And so he built up this framework for using JavaScript and tables where each line in the table would execute some JavaScript to do some functionality. And when he demoed this, people looked at it and said, yes, that accounting software is great. Talk more about this testing tool you wrote. And it obviously took off pretty well. The limitations of just executing on your own machine were pretty quickly apparent, and so finding a way to send commands to a remote machine was developed. I believe Google was instrumental in implementing some of these functionality. It came out in 2006. Selenium IDE, as I mentioned, also came about in 2006, trying to make it easier for people to generate those tables. Then the grid itself, where you could have a hub and a node and be able to register those, came about in 2008. The big change was in Selenium came about when people were looking at, as Selenium itself grew, there were some fundamental issues with the way that it was set up. Just executing JavaScript in browsers has a lot of limitations. Selenium 1 was designed as more of a testing tool and not just a browser automation engine. And that resulted in a lot of less object-oriented things and some there were like 6 different ways to do similar things, and you're never sure which one to use. WebDriver came along and said, let's pull all of that complexity out, focus on the underlying layer, and then we'll have this extra binary, this driver. And your code will send information to the driver, and then the driver is going to interact with the browser in ways that just JavaScript can't. So Simon Stewart at ThoughtWorks at the time was working on WebDriver, and I like to joke that Simon's somewhat pathological about maintaining backward compatibility. So he had this WebDriver implementation, and he spent a whole bunch of time rewriting it so that your Selenium code could be run backed by WebDriver, which was pretty intense. And then that was officially released as Selenium 2 in 2011. So the project had been around for several years, but it wasn't merged in officially until 2011. Selenium 3 was essentially pulling out all of the old Selenium 1 code from the Selenium 3 project. There was a lot of archaic things in there that we had to pull out, and that happened in 2016. As part of the W3C process, as part of changing the protocol that was being used by all of the browser vendors and the Selenium code itself, we were slowly adding functionality into Selenium 3. Theoretically, the code from Selenium 4 can be run on Selenium 3.last. That's the goal. And in most languages, that works well. So we've slowly built up this W3C implementation, and then Selenium 4 is going to remove the old protocol. So I'll talk more about what that looks like underneath. We're really hoping, Simon's added a bunch more features, and he's completely revamped the build system and the grid, and we're doing some things with Kubernetes right now. So there's a lot of things in the background that's happening with Selenium 4, which is why it is taking a long time to release, but hopefully that will be done soon, and it's going to be a really impressive and useful thing. And this does have some impact on Sauce Labs users, more so than non-Sauce Labs users, and I'll talk about that in a little bit as well. All right, so the first thing for using Selenium is picking a language. In general, I prefer, well, I'm coming from a Ruby background, so I'm always gonna say Ruby is a great choice, both because it is a strong dynamic language and because it has a lot of testing tools written in Ruby that make it really easy to work with. Both Capybara and Water provide a lot of that extra layer of functionality that makes it a lot easier for people to get what they actually want from Selenium rather than what people think that they're getting from Selenium itself. Python is also a great choice. It's unlike Ruby, its implementations are on the rise at this point, mostly because of the data library. So just more people are using Python, and that its overall usage is going up. It's another strong dynamic language, which is a really great choice for writing test code. C# and Java are the static languages that both provide a lot more structure to your tests. So there's a lot more things that you have to do, but there's also a lot more overhead that comes along with that. One of the big frustrations I hear from developers who are writing Selenium tests is, it takes me forever to write Selenium tests. There's so much stuff that goes into it. And C# and Java especially, there's so many layers of abstractions that you have to put into it. There's so many nested conditionals that you don't have to worry about in Python or Ruby because of typing and all of these extra things. It can be difficult. They make it very easy to get complicated in ways that are not useful. Okay, and then the fifth choice is JavaScript, which is its own kind of, it's probably the most different from these others. In the Selenium library itself, the JavaScript bindings do not currently have an active maintainer. If you are a JavaScript developer and are interested in working with the Selenium project, it would be great to have resources that are both steeped in the community and can help with essentially implementing the Selenium philosophy in those bindings. And so this is where I'll also give a shout out to Christian Broman and the WebDriver.io. WebDriver.io is not Selenium. It is an alternate implementation of Selenium using the WebDriver protocol. So it has its own translation that it is doing. And it's also, instead of just providing the low level interactions, JavaScript makes doing that just that more difficult. WebDriver.io doesn't even pretend to not be opinionated. It's opinionated. It provides a lot of the features that testers actually need on top of just Selenium. And so you get more out of the box right now with WebDriver.io than with other JavaScript implementations. All right, so browsers. These are the primary supported browsers through Selenium. Essentially, the goal with W3C was to be able to send the same commands to all of the browsers and have the browsers do the same thing. This didn't used to be the case. Things like, I think alerts is a great example. In Firefox, if you tried to take an action on the browser when an alert was present, Selenium won't let you do that because a user can't do something on the site if there's an alert present. So all of the browsers would raise an exception and say, you tried to do something while an alert was present. Well, Firefox would then be kind and close the alert for you so that you could continue with your test, where Chrome wouldn't. Chrome was like, no, you have to deal with this. And so as a library developer, I was like, well, let's check and see if there's an alert open, and then we can go down the path, one way or not, handle it or not handle it. And I couldn't do that because if I checked to see if an alert was present and it was, then it would go away and I couldn't work with the alert the way that I wanted. And so that was very frustrating for me. W3C now says, no, let's have a common way by default that we all do these things, and then you can override the default if you need to. So each of the browser vendors have put different amounts of energy into implementing all of the W3C features. If we take a look at this column right here, so first of all, the WebDriver Herald is a website that Jim Evans put together that ran all of the, I think he has a huge library of C# tests, and he ran all of them against all of these different browsers and then just put the pass rate for each of them. This data is about a year old, I believe. I think the last time he updated this was it was a pain to update, so it was all a manual process. It's about a year old, but these numbers haven't changed much in the last year. Internet Explorer, depending on what settings you set, is really well supported. Firefox, 98% range. Google is almost at 100%, which is one of the reasons why Microsoft Edge moved to Chromium. Well, they moved to Chromium because then they could, draft off of everything that Google is doing with the Chromium project. And so they're getting the advantage of all of this as well. And then Safari, you can see that Apple is really struggling there. And so the thing to keep in mind with your Safari tests is it might not be your code's fault if your tests are failing in Safari. It's entirely possible that you have exactly the right code, it's working in all the other browsers, but on Safari, you're getting a weird error. And unfortunately, one of the other issues with Safari is that the driver is actually a part of the operating system, which means that it only gets updated when the operating system gets updated, which is not nearly as often as Google and Mozilla can update their drivers. Another frustrating thing is that we've seen fixes in some bugs in subsequent releases that then also break things that were working in previous releases. And so Apple feels like they're playing whack-a-mole a little bit with some of the non-compliant aspects of the Safari driver. So it's getting better, but it's still not great, and that could be a cause of your issues. And so my test suites end up having some flag for Safari, where if I'm trying to run in Chrome, I'll run everything. And if I'm running in Safari, there are things that I'll skip over because I know that Safari can't handle them. And WebDriver Herald actually lists out, like the rest of this page lists out all of the million tests that are being run and which things are passing and failing in which browser. So what is Selenium actually doing? So that bold code right there that I'm writing in Ruby, driver equals Selenium WebDriver for Chrome. This is sending just that by default. It is sending a post command to, in this case, the local host, and 9515 is the default port for Chrome. So this is sending, or for Chrome driver. So this is sending the Chrome driver, the session endpoint, and it is sending both a desired capabilities package there. And then if you look on the lower right portion there, it's sending a capabilities package with a first match array. And so this is our handshake code that we're calling it. So this is Selenium 3 code, where we're sending both desired capabilities, which is the JSON wire protocol, and capabilities with first match or always match, which is the W3C protocol. We're sending them both. And we're saying, hey, endpoint, driver, whichever one of these you recognize, like send back the result that you recognize, and then we'll continue in the code using that. And so especially in Java, it's like, oh, we see you want JSON wire protocol. All of the commands are now going to be filtered through the JSON wire protocol classes rather than the WebDriver classes now, or the W3C compliant classes. Now, this has some impacts for Sauce Labs, which I'll show in a minute. But what we get back in this case, this is saying the Chrome driver recognizes that it's W3C, and so it's returning a value of capabilities, and those are some of the W3C compliant properties. And again, I'll talk more about that in a second. But the important thing with this to keep in mind is what Selenium is doing is it's translating your pretty code, whether it's Java or Ruby or WebDriver IO, whatever it is, it's translating the pretty code into these JSON blobs that are getting sent to endpoints. So let's put that in a big picture kind of context here. You have your code there on the left. In this case, it's written in Java. You have some kind of framework that you've built around it to handle your test logic that's also written in Java. Then you're using Selenium, in this case in Java, and Selenium is doing a translation between the Java code and then the JSON blobs and the endpoints. And that's what's getting sent to the, if we're running local, it's getting sent to the driver. You can see my lovely depiction of a browser driver there. Just like a bus driver, except for on a browser icon. And then it gets sent commands to and from the browser in some proprietary fashion. The way Google does it is different from Mozilla and different from Apple. They've got their own way of interacting with that, which is where the browser driver implementations come in. Now, that's for running on your local machine. Because we want to have some kind of remote connection capability, you can also go through a server. And all Selenium is doing with the server code is it's saying, we're going to just pass through the JSON. You send us the JSON blobs, tell us where it wants to go next, or we'll figure out where it goes next, and then we'll send the JSON along. So this can either be on your local machine, that can be on a remote machine, or it can be in some kind of grid. So that first server at the top line there, that's going to be on, like, so your local code can be, like usually what happens is you've got a CI server where the code and the framework code and the Selenium code all exist on one server. It's sending the JSON to a server on another machine. And then that server is sending commands to node servers on multiple machines. So this could be 4 different machines that it's sending code to, one with Firefox, one with Chrome, one with Edge, and one with Safari here. Now, this is very similar to what you're going to get from Sauce Labs. The implementation might be a little different, but the idea is all Sauce Labs doesn't see your code at all. All Sauce Labs is seeing is the JSON blobs and the endpoints, which are either, take an action or request for information. That's all we're seeing. We're not seeing the code itself. And so that's an important consideration when you're thinking about how Sauce Labs does things. So that's the basic of Sauce Labs. We've got a great new website and some new documentation, thanks to some work that mostly Diego has done for us. He works at Sauce Labs, also on the technical leadership committee for Selenium. The link is at the bottom for how to get involved if you're interested in working with the project. It's been very rewarding for me the past several years. All right, now let's get into more interesting things. Components of a Selenium test. So we have a demo site at Sauce Labs that we put together. A Selenium test essentially is comprised of 7 things. And I'm going to walk through, we're not going to put a whole lot of code in this talk just because it's Selenium 101, but we're going to walk through these things just as an overview. But basically, you have to open the browser, you have to navigate to where you want to test. The thing that a lot of people miss is the synchronization, but you have to find some way of synchronizing the state of the code and the state of the website itself before you can interact with an element. So you synchronize in some fashion, then you have to do some kind of location, or as part of the synchronization, there's a location, and then you perform whatever actions, you request information, you request actions to be taken. And then 6, because this is a Selenium test and not just a Selenium script, you have to make an assertion. A test is not a test if there's not some assertion that indicates the intention of that test. Then you have to close the browser and end the session. So in code, this looks like we're doing some Java things here. We're opening the browser by creating a new driver in this case. We're going to use the driver to get, or to navigate.to is another option, a specific URL. The synchronization comes in Java with a WebDriver wait class. So you're going to initialize one of those, and then you're going to use the expected conditions class to specify what condition needs to be true. There are different implementations that you can use now with lambdas, where you can create your own true false conditions and pass those in. There's a lot of flexibility when it comes to this. But in this case, we're passing in the locator. We're saying, wait until this is visible on the page, and then we can go on. Now that we know that it's there, we can save that, store that to a variable. And then in this case, we're going to click on that element, that button, and then we're going to make some assertion, whatever it is. Get the current URL. Are we still on the home page? And then we have to make sure we quit the driver so that the browser is not left hanging out there. So a full example of this, and all of my code is on our Sauce Labs training GitHub account. We've got a Java demo repo. It's a mono repo of all of the different code that we use at Sauce Labs. I make sure that everything that I put in a slide when I'm giving a talk is also on there so that people can find it and reference it as necessary. So that's great. That's a pretty simple, very basic, very pre-Selenium 101 approach. How do we actually use this? What are we actually doing with it? So I'll start out with talking about running this locally. The big thing you have to deal with when running locally is you have to deal with the drivers. So the driver, you can either put the driver in a location that is in the path environment variable in your operating system. So that's either in your bash profile in a Unix environment, or you have to go through the UI in Windows to add that path that those things are getting stored. Alternately, you can specify a specific location in the code. You set the property for where it is. You can store the drivers. The problem with both of those is oftentimes, and this happens a lot, we'll have people come to the Selenium help sites and say, hey, all of a sudden my test started failing. What's going on? And it's just like, oh, this is Chrome? They say yes. So what version of Chrome driver are you using? And then they'll give us some Chrome driver that's 3 years old. And Google did update some things recently where now they require the version of Chrome to be in sync with the version of Chrome driver. But the problem with all of this is the browser versions usually update automatically, where the driver versions you still have to manually download. And this is where option number 3 comes in. This is some kind of driver manager where you can set it to automatically update to the latest version. And so it will, every single time you use it, go and check and say, hey, for this version of Chrome, do we have the latest version of Chrome driver? This is an issue in all languages. When I saw this problem in Ruby, I created the WebDrivers gem in Ruby, and it's now being used by its default in Rails and Capybara and all of those things now, which is just great usage for that. Python has several implementations at this point. So whatever language you're in, that might be a way to do if you need to execute locally. So what about executing on Sauce Labs? First of all, you have to get your user information. It's this user settings page. I have blanked out my access key so that you do not steal all of my tests. Thank you very much. But you're going to get your username and your access key. And in general, we recommend putting that in an environment variable. We really don't like it when you store credentials in your code that then gets added to your version control system and gets put out on the web. We have seen people put their Sauce credentials in public GitHub repos, and we've had to go and cancel those accounts and let them know, or cancel those access keys and let them know that they need to change it and make it private. You take that information, and in this case, we are going to specify, you can say line 11 and 12 there, where we're getting those environment variables and passing that into the URL in line 14. But the thing to pay attention to is the way that this is essentially the old way that we would recommend people create their capabilities. There'd be a desired capabilities class instance, and you would use the set capability method with the capability type enums for each of these. And you can see that the first 3 are the standard values that everyone uses. And then the last 4 there are Sauce Labs specific capabilities. idle timeout, screen resolution you want, the name of the test, the build name. Those are all things that you pass in that Sauce Labs will read and process for you. And we'll get to what's going on there in a second. So you're essentially just creating a new remote web driver with the URL for Sauce Labs and the capabilities. So what's the problem here? Problem is that W3C came along and said, these are the only ones allowed on the top level. This is all you get. These are the things that you get to set directly. Anything else that you want to set has to be namespaced. It has to have the organization : keyword in order to do anything. And in Sauce Labs case, we decided to go with sauce : options, and then you would pass in some kind of dictionary or hash map for that. And so this is what it's looking like now for what you need to do in Java. Java made things easy for people running locally. It made it a little bit more difficult for running remotely, just because if you have third-party options, you now have to use this new mutable capabilities class. And so now we're creating a sauce ops instance in line 1, and we are setting all of the Sauce Labs specific things in lines 2 through 8. Then we're going to create, we're no longer, well, we are no longer using driver desired capabilities dot browser name in order to get that. That used to be one thing that people would do. That's now officially deprecated. The recommendation is always to use the browser options classes. And so in this case, we're going to Chrome options instance, and we're going to pass in whatever Chrome specific things we want to that are only for Chrome. And then we're going to create a desired capabilities instance, and we're going to specify the things that are W3C compliant in those lines. In this case, it's lines 15 through 17 here. And then line 18, we have to pass in the Chrome options that we created in line 10. And then in line 19, we have to pass in the sauce options that we created in line 1. So we're taking all of those things, and note in this case, line 7 and 8, we put the username and access key actually in the capabilities and the payload rather than in the URL. You can still do it either way. But we're taking this way, and we're just taking the basic URL, and we're taking the capabilities we created, and we're passing that in to initialize the driver. So lines 15 through 17, those basic things, we want a Chrome browser with a version 80 and a Mac OS 10.13. Where do we get that information? Sauce Labs, that means using the platform configurator. You figure out which one you're using, the W3C standard at this point. We want a PC, Windows 10, Chrome 83. This is what the code that we need to use looks like down below. So we generate this code for you. You can copy paste this. So note that the last line there, sauce options, that's essentially empty. One of the problems that we have is when our users send us a session request that includes Sauce Labs specific values at the top level like they used to, we're not certain, we can't tell if you want a W3C or a JSON wire protocol. And we're defaulting to not try and guess what you want. And so we're defaulting to the old JSON wire protocol. So there are a lot of people requesting information on browsers that default to W3C, but we are putting you into JSON wire protocol mode in order to work, in order to make sure that you're getting what we know you want. So we want people to update their code so that they can make use of the latest W3C, so that we can update, so you can update yourself to Selenium 4 and the latest functionality for the actions classes especially, and some of the advanced features that you get with toggling specific ways to do things with the different browsers that you get with W3C. So specifically with the sauce options here, you can see it's blank here. What things can go in there? We have this test configuration options page that will list out all of the Sauce Labs specific things that can go in there. One of the alternatives to you creating a mutable capabilities instance and passing all of these things in and making sure you know what goes where, we have created sauce bindings. So we've got sauce bindings available in Ruby and Python and Java right now. We're working on getting mobile support for that. Right now it's just a Selenium options. But essentially, you're going to create an options instance. You're going to pass anything. So this Chrome options on line 1, this is coming from Selenium. This is a Selenium class. Sauce Labs is like, we're not trying to reproduce what Selenium is doing. We're trying to add on Sauce Labs specific things to what you're doing. This is explicitly trying not to have vendor lock-in. We want you to either be able to pass in your Chrome options to a desired capabilities class or pass it into a sauce options class. So you create your Chrome specific things, your browser specific things, then you initialize a sauce options instance with what you created, and then you're going to set all of the specific values that are either W3C or Sauce Lab specific values, and you just set them directly. And we've got explicit setters and getters for all of these things. So it is, from your IDE, you can see exactly what things are allowed. We have enums that are required for the type to make sure that you're getting exactly the right string. Sometimes it's difficult to remember, okay, it's lowercase MAC, but uppercase OS space, and then it's 10.13, or you can just use an enum here, which is a lot easier. So then in order to get the driver, you initialize a session, passing in the sauce options you created, and you hit start. So this is a lot easier. We're definitely looking for feedback. We released 1.0 last month, and we're still collecting feedback from people. So far, the response has been really positive. It's a great way to get W3C compliant code in Sauce Labs without having to do a whole lot of figuring out of new classes. All right, and then Sauce Labs dashboard, we can just see that when you're running with the different capabilities, you can see that the basic running different browsers and operating systems there on the right as we go down. All right, let's move on to locating elements. Hopefully everyone is familiar with the document object model. Hopefully everyone understands the nested tree and how to locate different attributes and properties on elements in this tree. We find all of this by right-clicking on something and inspecting and taking a look at the values in the Elements tab. There are 8 ways to locate an element in Selenium. ID and name are often unique. ID is supposed to always be unique, but there's nothing that forces that in the website. Names are often unique in forms unless they're like radio buttons or things that are grouping a collection. So those are often good ways to locate something if you have them. Class names and tag names are usually not unique. Tag names don't often change, but class names do. Every time you redesign a site, you're going to have different class names for everything. And so if you have a lot of elements that are located by class name, large or small changes to how your site is designed could cause your tests to break when the system is still working correctly. We call that brittle. You've written brittle code by using class names rather than something that is more robust and is more likely to still work after changes, intentional changes are made. Link text and partial link text, these are based on the text of the site. It's only for links that are supported directly by Selenium. In general, we believe text to be more brittle than using attribute values in the code. And this is a little context dependent. Maybe your code changes, your attribute key value pairs change a lot more frequently than the text of the site. But in general, use the link text very sparingly. But since we don't have the usually unique things for all of the elements we need to work with, pretty much everyone is left with using either CSS or XPath. And I'll talk more about those in a second. Just examples of locating something. For the examples of class names or tag names where these things aren't typically unique, you can do a find elements call, get everything, and then use a get from the returned array for which element you want. All right, advanced element location, CSS or XPath. There are only 2 things that XPath can do. that CSS can't. The first is that XPath can traverse the DOM in any direction. That means you can locate an element. So as part of a locator, you can say start at this element down here and then work your way up 2 levels and then 1 to the left, and then that's the element we actually want. CSS, you can only nest things down and then subsequent siblings. The other thing that XPath can do that CSS cannot is it can locate elements by text and partial text. So Selenium allows you to do that with links. XPath allows you to do that with any element. Those 2 use cases should be very rare. You shouldn't need to do either of those things for almost any location that you're doing. In which case, I heartily recommend and advocate using CSS over XPath. There is a lot of people say that there's something inherently wrong with XPath for, it's slow, it's not supported well. I have not had any problems with those things in XPath. The biggest issue with XPath is in order to write good XPath, and most people write bad XPath. Most people don't realize that, oh, text equal is different from normalized space. And when you're doing looking for a class, we really should be able to do something where you're translating uppercase and lowercase. There's a lot of things to write good XPath. I've written for Water locator system, essentially a hash map key value pair to XPath conversion engine. And getting the right XPath is not simple. So XPath is great for interacting with the computer, but most people don't parse it as well. CSS is both more human readable to get the correct CSS, and also it's better understood by your front-end developers. If you ask most devs what XPath is, they're going to get confused and start doing Google searches. They have no idea. But if you ask for help on the CSS classes, they're like, oh yeah, I did 10 of these just like this last week or yesterday, whatever it is. Okay, I'm not going to belabor that. So basic information that you can get from Selenium. What is the text value? What is the tag name? Specific attribute names. CSS values where you get things like style information, location or size of an element, whether an element is displayed. So this is the big Selenium specific thing that you don't get just by parsing the HTML with some HTML parser engine. W3C removed the endpoint for displayed. Essentially, in the W3C meetings, there was lots of argumentation and discussion about how do we programmatically ensure that an element is visible to a user on a page. And there was no way that we could do it where all of the browser vendors said, yes, this works for us. And because there was no way, it's one of those really, David Burns had a great talk about this at a Selenium conference a few years ago, I think in London. We're talking about just all of the complexities involved with trying to figure out that. What the Selenium project has done is it has created this huge, crazy, complicated approach to all of the different things that we think may keep something from being displayed. We make a lot of values, and we use Google Closure to generate this huge JavaScript blob that we then shrink down into an atom. And it used to be that the browser vendors would take that JavaScript blob, put it as part of their driver, and whenever you called the displayed endpoint, the visible endpoint, it would execute that JavaScript code for you. So it was just one command. Now though, since we can't assume that that endpoint exists because it's not W3C compliant, the end user, Selenium itself, instead of sending a command to that endpoint, it is taking that 45 kilobyte file and executing it against the execute script endpoint. So this is more of an issue on a remote execution like Sauce Labs, where if we're making a whole bunch of displayed calls, that's a lot of information that's going back and forth over the wire. So it's one of the ways that I help people optimize their code on Sauce Labs is by minimizing the number of times you have to make that call. Then it'll ask if something's enabled, it'll ask if something's selected. Actual element actions, there's not that many. You click, you can send keys, you can clear a text field. and you could submit a form. Now, submit is another one of those things that we removed from W3C. So if you're calling submit in the latest code, it is, again, going to send some JavaScript to do that. So I highly recommend not using submit and just clicking the button that you want rather than using the submit method. It is more close to what the user is actually doing than, which is the goal of us testing things with Selenium. Advanced element actions, there's a whole actions class. This is completely revamped for W3C. This is all of the keyboard interactions, keys down, key up, key, mouse movements. You've got pen movements, mouse keys, touchscreen. There's all sorts of different input devices and interactions that we now have a whole interface to facilitate interactions with the UI that we're working with. So browser actions, I dig into this a lot more in the Selenium 201 course, but essentially you can get the title and the URL as the basic information. You have to do all of the navigation, forward, back, refresh is all supported. Being able to work with windows or tabs. And there's some tricks to some of the ways that is now implemented. Dealing with browser context, so this is digging into frames or iframes. Another common issue that people come is like, I know this element is on the page, but Selenium's not finding it. First question you always ask is, does your site use iframes? They say yes. It's like, all right, you have to explicitly switch from the top level browser context into that frame in order to see the elements in that frame. It's like a separate HTML page or a separate window within the window. JavaScript execution, I mentioned this a little bit before, but you can execute any JavaScript in the browser and either take the action or get information back that way. Cookies, this is reading the cookies that are there, getting the, setting a cookie. I guess I could also put local storage is also supported. So reading things from local storage or setting things from local storage is also supported. Working with files. Now, upload's pretty straightforward. Download's the tricky one. Again, we're talking about download is more of an operating system functionality than just a browser functionality. And so often there is an operating system prompt, which the browser can sometimes skip past, but it's something that has to be explicit. In general, we recommend against people doing downloads. Very few features that you need to test actually downloading something. Very few features, the best way to test it is actually downloading something. There's a better way to test what you're trying to do rather than downloading the PDF and then parsing the values and then making sure that that's what you set. It's like, so you're testing the PDF creation. How about an integration test to make sure that the inputs that you're sending there, like what is the right input? Are you making sure that that's getting to the generation down at a lower level rather than doing it at a higher level? Pretty much that gets into best practices, and that's a whole nother talk, but essentially don't do anything in the browser if you don't have to test that functionality, because browsers are complicated. And then JavaScript prompts, so these are the alerts, like alerts with text or just confirmation alerts, things like that. And I mentioned earlier, Selenium won't let you take any other driver action if an alert is present on the page, because a user can't do that. But as part of what the W3C has done is it said, here's 6 different ways that you can always auto accept alerts that pop up, or you can ignore errors when alerts pop up and you try and take another action. So you can specify now the behavior you want with them, but there's a bunch of different actions you can take there. And then the final thing I want to talk about is actually using Selenium in the real world. This is really where, this is the part that I really dig into in the more advanced Selenium talks. First thing is just talking about using Selenium in the context of a test framework. And when I talk about a test framework, I'm very broad with my definition. It's essentially all of the tools that you're using for your UI testing purposes. And so this is going to include all of the helper libraries. It's going to include any data abstractions, any page abstractions, however you're configuring your data. Are you using, faker libraries or some kind of test library for randomizing data? All sorts of, what is your test runner? What is your build tool? And the reason I'm very broad about all of that is just so that people realize when I'm talking about ideas for how to improve what you're doing, everyone has a different list of things that are successful or more successful or less successful for the context in which it's being applied. And so your test framework might be perfect in one context, but horrible in another. And maybe that's fine for what your use case is, but realize that there's something that can always be better. I think one of my most frustrating responses to a talk I give is I lay out all of these suggestions for people and then come back and say, oh yes, we're already doing those things. And almost always then they'll start talking about like, yeah, we're doing this. And I was like, I literally said not to do that. And it's a whole thing. But realize underneath it all, the whole point of a framework is to reduce the maintenance costs, which are the most expensive part of dealing with a test strategy, is trying to keep up with the results and try and keep up with known correct changes to the system. And that's dealing with flaky tests, dealing with brittle tests, and trying to find a way to deal with all of that. So I've got a list of 8 components of a test framework. And I could probably do a half hour. I've done full hour talks on some of these. I can do at least half an hour on most of them. But essentially, the assertions that you're making and how to make assertions, that's what makes a test a test. The initialization and the cleanup, what all goes into creating, like before the test, what do you have to do at the end of the test to whatever your reporting is or your ending session or storing information in places. Data modeling, this is really important for being able to execute tests in parallel. A lot of people have bad data modeling that's very restrictive, and finding better solutions for modeling your data is very useful. Configuration, finding ways to avoid, man, I've seen, especially in Java, you'll see like 1,000 lines of like all of these nested conditionals to handle what are essentially strings. And it's like all of that stuff could get pulled from a file, things that aren't changing. If you're not processing that in some way, if you're not doing something with the information that requires, programming logic, it makes a lot more sense to pull that out and put that in some kind of serialized information file. All right, then you've got synchronization strategies. This is the whole trying to deal with flaky tests by doing weighting properly. A lot of frameworks are designed, they're optimized for running remotely, where it doesn't matter how many wire calls you make, they all happen in milliseconds, and that's fine. That gets a little trickier when you are running on Sauce Labs. So every single call, there is some latency involved, and so it's a non-insignificant amount of time that's being taken for each call. So finding ways to optimize that is super useful. And I've seen some really, really crazy, horrible things that some frameworks do because they're not taking that into account. And that's going to apply to Sauce Labs or any remote execution on a remote machine of any kind. And one of the things that I've done, like Water in Ruby does a really great job of performance optimization of only making the necessary wire calls. I've been working on a project in Java called Salsa Verde, which, and it's probably at MVP state, but it's still really rough, and I'm definitely looking for users to help out with it. If you're looking to do some kind of greenfield work in a testing platform with Java, it's designed to work really well with remote and to provide a pretty straightforward interface with dealing with test data and page object implementations. Something to, anyway, if anyone's interested in that, let me know. We can talk more about those things. Wrappers and helpers, a lot of things about encapsulation and doing subclasses and making sure that different elements are being able to make the right calls for these things. And then APIs. And I mentioned before, anything you don't have to do in a browser to test something, try not to do it in the browser. And so oftentimes the test setup and the validation, I will use a REST client and the API to create the stuff that's needed in order to test the feature, and then to validate that all of that actually happened correctly. And so the teams that are most successful with their testing, in order to have short, atomic, autonomous tests, tend to make really good use of the APIs that the developers have already provided you. And a lot of teams that are still struggling to figure out how to improve things, many of them don't even realize that those things are available to them. All right. That is what I have. If anyone has any questions, I think we've got a couple minutes.
Looks like we have a question in the chat there, the Zoom chat.
Yeah, let's see what we have here.
There will be recordings sent out, so no worries there, but I think it's the previous one that might be for you, Titus.
Is it recommended to use Selenium Grid in Sauce Labs? Session info on getting it integrated. You can implement Sauce Labs in a grid setting. Diego actually put together a whole Selenium project that kind of coordinated some of those things. It's an open source tool. Diego now works at Sauce Labs. For the most part, it probably isn't needed depending on the scenario that you're in. Sauce Labs wants to be the entire platform where you just run it and we do everything that you need with it. So talk to us if there's some specific use case that you think you have for integrating it as part of the grid. Theoretically, it shouldn't be necessary. Oh, and Marcus is chiming in. Marcus knows more about the grid than I do by a long stretch. Marcus is my boss, so I have to say nice things about him whenever I talk about him.
You really don't.
Well, I also the one that convinced him to come work at Sauce Lab, so it's kind of a mutually beneficial thing.
True story. Something we're trying to release as open source as part of the Selenium project is the idea that if you have an existing grid that runs Chrome, but you're tired of having to maintain all the different versions of Firefox and everything else, that you could attach this node and it would just operate as Sauce, and you wouldn't even have to know about it, really. Just you configure it once and forget about it. That's still it works, but it's a prototype, and it's got all the drawbacks of a prototype. But it's something we're trying to work on.
So I think we're closing now. And if no one has any more questions, I am available on Twitter at Titus Fortner. I don't post a lot, but what I do is mostly testing related, so there isn't a whole lot of spam in there. And obviously, I'm available at Sauce Labs to discuss any issues that you have with our service or anything test related. I love digging into code. And so if you've got things that might be able to talk about optimizing, I'm all about it.